Right, looking at this old unit because it's tripping the overloads out. It's an old cellar cooling unit. Somebody's bodged a little receiver in there. You can see they've brazed that pipe into a flare fin. Let's see what it does. That's the contactor for that little unit. It's a 3-pole contactor. That's the overloads. Set around 11 amps on the side there, so that's not too far out. But it's only got 2 wires run through it now. These are always set up for 3-phase, so it needs to have 10 amps. Well, up to 10 amps on each one of these legs for it to not trip. If it's got nothing on this one, it assumes it's 3-phase and it's lost one of the phases. Now, how that has been working for all these years and not tripping, I don't know. But that's what we found. Right. That's our live and neutral. I've put a wire in so that neutral comes down through the contactor on that wire, which loops around to the top and then comes through, and then that's our live neutral to the unit, and our live just goes straight through. So each one of these now has 10 amps going through it, so it should only trip it if it's over 11. So we'll try that and see, I think. But it's been in for years, so how it's worked for 10 or 15 years like it, I don't know, unless that compressor's getting a bit tired and it's pulling a little bit more current. There's a delay on the controller. Right, about 3-minute wait. That's brought the vac fan and the compressor on. In fact, I think the vac fans run all the time, so they're probably not wired to this. I think this is off on the reset. There we go. Now we'll go and check the capacitors on the compressor. We've got a couple of other things to look at, so we can, if they check out okay, we'll leave it running for a bit and see what happens. You can check the reset button is working okay. You should hear the contactor drop out when you press the button in, assuming it's running. Well, the wiring on this doesn't seem to be much better. Got our live in on that red. The red wire goes down to the Clixon, and these are usually in the neutral. I seem to remember that probably should be the neutral. Then we've got black wire, which goes to the neutral, so assume that's the run winding, and the yellow wire goes up to black wire. So we've got live in here. If the Clixon's okay, it can get to here, and gets to the neutral there. That's a start winding connection. The yellow wire comes up here, goes onto here, and that picks a neutral up off of there, where it's piggybacked off of that down to there. So that's permanently connected, so that's like the run cap. It's got a relay, so it should have a start cap. Then we've got this white wire, which is connected to the other side of the Clixon, but what is that doing? If you've got a live coming through here anyway, when that's made, what's the point of this? And that comes up to number 5 on there. I'm going to have to get the diagram out for these, but unless that turns the relay off if the overload goes out. Anyway, then we've got, off of the capacitors, we've got this one that's already connected to the start winding. There's got a wire up to here, and then we've got our other one, which goes onto there. So maybe that just joins them two capacitors together. And normally you'd have the start winding on one of these, the run cap next to it, and the start cap below it. So that all seems a bit odd. Right, well, we've got the lid off the relay. Let's see what happens. That should pull in once the thing's started. What it should do. Alright, leave well alone I think. Put the lid back on that and we'll put that relay back together, and we'll check these two capacitors, make sure they're what they should be. I think they're 25s.